All right, we need to go back and we now need to talk about mole conversions. You guys have done the PDawg, the relative mass, and the mole. We did that before Christmas, and so we now need to revisit that and start doing some mole conversions and how other things convert into how we convert other quantities into moles, because moles are how we really do chemistry. That is the chemistry quantity. So a quick review on that. We have, okay, what is a mole? Okay, the mole is 6.022 times 10 to the 23rd of anything. Okay, but we usually talk about atoms or molecules. We usually talk about atoms or molecules when we're talking about a mole. And the reason we have this number is to create a bridge between the microscopic or the submicroscopic to the macroscopic. So from really, really small things to things we can deal with. And and so this is the crux of it, that if you have one atom of, say, one atom of carbon. Okay, in fact, we're going to call it carbon-12. One atom of carbon, the isotope carbon-12. If you have one atom of it, it has a mass of exactly 12 atomic mass units. Okay, but if you have one atom, if you have one mole, okay, if you have one mole of carbon-12 atoms, these guys have a mass, it has a mass of 12 grams, and this is what the mole does. Instead of paying attention to each individual atom and counting all of the AMUs and then extrapolating to a really large amount that we can use in the laboratory, we count moles. And since one mole of carbon-12 atoms would be 6.022 times 10 to the 23rd carbon atoms, if we have that many carbon atoms, we're able to take this value, this number of AMUs, and convert it straight into grams. Okay, so how it related to your PDawg was you had clusters. Remember they talked about clusters, yeah. And if you had, if you knew that one big egg compared, like one ostrich egg compared to one chicken egg or whatever it was, and you knew that an ostrich egg weighed 16 times that of a chicken egg, but if you had a cluster or cluster cluck was what I preferred to call it, a cluster cluck of ostrich eggs versus a cluster cluck of chicken eggs, they would still have the same 16-to-1 ratio. That if as long as you have the same quantity of them, that the relative masses will be the same, and that's what's going on here. If we have, this is one atom of carbon-12, has 12 AMUs. Let's say we have an atom of hydrogen, it's going to have 1 AMU. Well, if we have 1 mole of carbon-12, it's going to be 12 grams, and 1 mole of hydrogen is going to be 1 gram. And so the ratios stay the same. It's just that this number right here is what allows us to go straight from AMUs to grams. That's why we have this number. Okay. So there are other things that this mole allows us to convert to and from. So we need to write these conversions out and show how they apply. That one mole equals 1 gram atomic weight, okay, of an element. Okay, that's just this right here. This conversion means gram atomic weight. So if you take whatever you get on the periodic table, that's the atomic weight. Okay, you put G after it, and that's how many grams you have. You guys follow that? Okay. Next one is if you have 1 mole of stuff. Is if you have 1 mole, you also have this many particles. Okay, we call this the mole of the chemist's dozen. If you have a dozen of something, you've got 12 of it. If you have a mole of something, you have that number of it. You've got Avogadro's number of it. Okay, and the third one is a new one. And we haven't talked much about gas and volume and that sort of thing. But if you have 1 mole of a gas, okay, equals 22.4 liters of volume at STP. Cute. Okay, so you may be asking yourself, what's STP? We've never heard of this before. STP means this. STP means standard temperature and pressure. Okay, the standard temperature equals 273 Kelvin, or 0 degrees Celsius, or 32 degrees Fahrenheit, which is not much colder than what we have outside right now. Okay, pressure, standard pressure is one atmosphere, and that's all that I want you guys to worry about right now. There are other conversions for atmosphere, other versions of what the standard pressure is, but they all physically mean the same thing. They're just different ways of measuring it, and that gives you different units. So this I don't want you guys to overly stress about, like memorizing it, that kind of thing. Not important. What is important is this conversion right here only works at STP. Only under these conditions does 1 mole of gas occupy 22.4 liters. You guys follow me there? Okay. If it's warmer than this, it's actually going to occupy more space. If it's colder than that, it's going to occupy less. Gases expand when they get warmer, that sort of thing. Okay. Okay, so we're going to create the mole island. The mole island archipelago. You guys know what an archipelago is? What? It's what? Zach? It's a chain of islands. That's right. Hawaii is an archipelago. The Aleutian Islands are an archipelago. Japan is an archipelago. The Philippines are an archipelago.
Would Indonesia be a big one?
Indonesia is a large archipelago, yes. Okay. All right, so the mole island archipelago starts with one central island. Okay, this is Mole Island. It has 3 outlying islands. You should draw them big enough that you can write inside of them, or at least write the title. This is Graham Island. This over here is Gas island. And down here we have particle island. Okay, and this one you can't see right here is fantasy island. You can't see it, but it's over here. You know why you can't see it? It's fantasy, right? Okay. So, to further make Mole Island more realistic, we need to draw the little hairs growing out of it. But if we do that, then we need to call it Grandma's Mole Island. All right. This may or may not be dedicated to Foster's grandmother. Maybe, maybe not. Yeah.
Joseph's mom.
Okay. All right. So the first one that we are going to talk about is okay. So here's the idea of the Mole Island archipelago. We have these different units that we're going to convert to and from. We will either have liters of gas, we'll have grams of stuff, or we will have atoms and molecules, numbers of atoms and molecules. Whatever we do, we will always be converting back to Mole Island. Okay, we need to figure out how many moles we have of something, and so that's our baseline. Now, sometimes we'll convert from, say atoms to grams. If I have so many atoms of something, how many grams do I have? In which case, we will need to go through Mole Island to get out to Gram Island. Okay, so we're doing some island hopping. The idea is this is the hub. This is the hub island, and we have to go through the hub in order to get to an outer lying island. Yeah? The hub would be the main island, right. Well, you can call this Oahu if you want. Okay. All right. So here's our big map. We will be coming back to this, so that's why you need to keep it separate on your page, and don't draw the next stuff on this page. Okay. Right. This is the map. This is the left side of your map so far. All right. So here's a question we're going to answer. The question we're going to answer is okay. 2.5 moles of NH3 has what mass? Okay. This word right here should lead you to Gram Island. Okay, mass is in grams, and so we should be referred to. Okay, whenever we see the word mass, we should be referred to Gram Island. All right, now, our conversion for this, if we have 2.5 moles of NH3, how much does 1 mole of NH3 weigh? Does that show up okay? Yeah. Okay, 1 mole of NH3 has a mass of what? How are you getting that? 2333. I'm looking for 1 mole of NH3. Okay, so how do we find the molar mass of something? You guys remember this? Okay. We have our nitrogen here that has a mass of 14.01. Okay, and we have 3 hydrogens. And those are 1.01 each. And so that gives us 14.01 plus 3.03, which is a total of 17.04 grams per mole. You guys remember this? Okay, how we find the molar mass, where we find the AMUs for each atom, and we add them together, and that's the total AMUs for the molecule. And that's what 1 mole of it is, that many AMUs in grams. So this is 17.04 grams per mole. This is called the molar mass. Okay. So if this is the mass of 1 mole, 2.5 moles would be what? By 3? So we're going to start with 2.5. So we have 2.5 moles of NH3. And we're going to multiply it, or we're going to put it into our dimensional analysis grid. We have 2.5 moles of NH3, but we know that each mole of NH3 has a mass of 17.04 grams. This right here, this fraction, means this. You guys see that? 17.04 grams per mole means 17.04 grams per mole of NH3. Yeah? Okay, this is the same thing as multiplying fractions. So what do we do here? No. We just multiply. Okay, we cross cancel our units and we multiply to give us 2.5 times 17.04, and I don't have a, I'm sorry?
42.6.
42.6, thank you, equals 42.6 grams of NH3. Ta-da, 2.5 moles of NH3 has what mass? 42.6 grams of NH3, because we multiply. Now, how does that apply here? If we go from Mole Island to Gram Island, what process did we do? We multiplied by our molar mass. So this is going to be multiplied by molar mass. Okay. All right. So now we're going to come back. Okay, so how many moles of CO2 are in 23.6 grams of CO2? Well, we've got grams again, which means we're going to use Gram Island, but this time we have this number, right? Whichever unit we have tells us where we start. We're going to start on Gram Island, and somehow we have to get back to Mole Island.
Swim.
Swimming is not an option. It's a long, long way.
Oh, that's a good one. That is a good one. Oh, man. Shoot. Last time I heard that one, I was like, dude, look at Jesus.
That's a low blow.
Okay. Stop it. We're recording. Okay. So. So instead of multiplying, we have Mole Island, we're trying to get out to Gram Island, where we multiply by our molar mass. If we have to return from Gram Island to Molar Island, we're going to do what?
Divide by
We will divide by our molar mass. So we come back over here and we start with our given, which is 23.6 grams of CO2. This time we need to divide. So down here, we need to put our what? Down below, we put the molar mass of CO2. Okay, so I'll give you guys a moment to figure that out. Because you have in the back of your periodic tables, back of your notebook, you guys should have your periodic table. It should be there. If it's not there, that means you didn't fasten it in place like you should have. Okay, you're taking too long. So, that should be 44.01 grams of CO2 equals 1 mole of CO2. Cross cancel our units. Multiply across, divide, and we get, Nick, you on that? Too late. And this winds up being 0.536 mole of CO2. Okay, so what was our keyword here? What did we find in this that told us which conversion to use?
Grams.
That unit right there, that grams, told us that we're going to use Gram Island. Okay. Gram Island. Next we have Particle Island. And we're going to go back and forth from Mole Island to Particle Island. So, okay, how many atoms are in 0.276 moles of helium? Okay, what do we have to start with? What's our given? We have moles, right? What keyword is going to tell us the island we start at? Atoms right here tells us that we're going to start at Particle Island. Because atoms are particles. Yeah? Okay. Well, from our conversion factors, how many particles are in a mole? Look at your earlier notes. Your notes from just 20 minutes ago say they're at 6.02 times 10 to the 23rd. Okay. So we start with 2.76. Or 0.276. Okay. Here's mole of He. We want to cross cancel our units, so mole of He will go on the bottom. And we know that 1 mole of helium equals how many particles? And so what would we do? Cross cancel the units. And multiply. So 2.76. So 0.276 times. And if you have not yet figured out how to put this into your calculator, Google it. Because you obviously haven't been listening to me. All right. 6.022 EE23, and then equals, figures it out for you, and so this would be 1.66 times 10 to the 23rd. That's what this means. E23 means times 10 to the 23rd atoms. Okay. So we come back to our map. Come back to our map, and here's Particle Island, and we just discovered that if you go from moles to particles, we do what? We multiply by 6.022 times 10 to the 23rd per mole. And I don't have a unit on top of that because there really isn't one. This is just things. It's whatever you're counting. Okay, so in this case it was atoms. It could be particles, it could be molecules, it could be whatever. All right. Next question. Okay, that's the new question. What is our keyword? What are we looking for? Molecules. Right there. That molecules tells us that we are going to start over on Particle Island. Molecules tells us here, Particle Island. So, the other thing that will help direct you to Particle Island, if you see an exponent like that, okay, and your heart starts to race a little bit because we don't like big numbers like this, we don't like dealing with them. Our best tool against this, okay, is dividing by Avogadro's number. It makes the number smaller. Okay, think of it as a weapon. Okay, fight the fight against large numbers. Here we go. So we start with our given. Okay, notice, by the way, I gave you this big old molecule, right? Do you have to find the molar mass to do this problem? No. So don't freak out just because you see a molecule and you know how to do molar mass doesn't mean you should. Just because you can doesn't mean you should. Kind of like smoking. All right. Not that any of you can, but all right. Life lesson to you, you know. Okay. So we have this many molecules, but we need to figure out how many moles we have. So we want units of moles. And 1 mole of this stuff equals how many molecules? 6.022 times 10 to the 23rd molecules of glucose. Because that's what C6H12O6 is. Okay. Back to the calculator. So, there are two ways you can go about this. You can take 1.204 divided by 6.022, you get a decimal, and then 10 to the 25th divided by 10 to the 23rd, and then multiply the two together. Or you put it on your calculator. 25 divided by 6.022 EE23, and you get 20. Yes, I chose that intentionally. Okay. What's that? I knew it would be really close to 20. I've also been teaching this class for a really long time, and I've been using 1.204. That's, yeah. Okay, and this winds up equal to 20.0 moles of C6H12O6. And that brings us back to our island over here. How do we go from particle island back to mole island? We divide by 6.022 times 10 to the 23rd per mole. Yeah? Yep. Question so far? We're almost there. Okay. Based on the pattern you see, what should I put over here? Multiply by what? Why multiply on this particular one?
Because on all the other ones that you go from the top to the outer, you multiply.
From mole to the outer island, we multiply. Multiply by what's going to go here? No, it's the other conversion that I introduced to you guys, but we haven't used yet. 22.4 liters per mole at STP. Yep. And down here we would have what? Divide by 22.4 liters per mole. So, y'all ready for this? Dun, 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 dun. Okay. Here's our question. Okay. So here is the cumulative question to see if we know what we're talking about here. We have 48.4 liters of nitrogen dioxide at STP. And that has what mass? What are our keywords? Okay. STP is a keyword. What else? Liter. What else? Mass. Okay. What island on our archipelago are we going to start on?
Gas.
We start on Gas Island. Why do you know that?
Well, because it's at STP.
We start here on Gas Island because this value is given to us.
Yeah, that's what
We have this number of liters. We know this number, and whatever our given is the island we start on. Then we are going to what island?
no, grams Grams Island.
We will end on what island?
Gram.
We will end on Graham Island because we're looking for mass. We have liters. We need to find mass. What path should we take?
No, you have to go to mole.
Okay. We have to go to moles, so we're going to divide by 22.4,
And then multiply by molar mass.
and we'll multiply by the molar mass. Yeah? Okay.
Why can't you just jump from island to another island?
What's the conversion? Aha. So we start with 48.4 liters of NO2. Okay, the step was divide by molar mass. So okay, so we get to here to 1 mole of NO2. That puts us here on Mole Island, right? Then once we're on Mole Island, what do we do?
We have to jump to gas island.
Then we have to multiply by molar mass to get to that.
Then we multiply by our molar mass, which is so many grams of NO2 for 1 mole. Well, NO2 is, N is 14.01, oxygen is 16 twice, which is 32, 14 and 32 is 46. .01, right? .01? Yeah, I think so. Grams of NO2. It's going to be this times that divided by this. You can do it in order, but I recommend when we, because we're going to do some long ones here eventually, that you do this times this times this as you multiply across the top, and then divide by each thing individually on the bottom. So that becomes 48.4 times 46.01 divided by 22.4. That one I didn't plan. Okay, this should be 99.4 what?
1/4.
Grams.
Mm-hmm. Those units canceled. Those units canceled, leaving us with grams NO2. You will be expected to go from any island to any other island for your quiz and on your final. But when you know your map, it's not that big of a deal. You can go from island to any other island. Okay, if you follow the arrows, it'll tell you exactly what you need to do.
So we should study on that.
So learn the map. Right? Okay, where is your map? Oh, it's in your notebook now, right? Perhaps you should be looking at your notebook and studying the notes that you have in your notebook. Okay, that is it for this lecture.